Hello guys, welcome back. So here we have another question on communication systems from GATE EC 2022. Consider a real valued source whose samples are independent and identically distributed random variables with the probability density function f of x as given in the figure. So f of x is given. We have the distribution from -2 to 1, and if you see, the amplitude is not given. So we can find it using the fact that the integration of this should be equal to 1. Okay. So then what they are saying, consider a 1-bit quantizer that maps positive samples to value alpha and others to value beta. If alpha star and beta star are the respective choices for alpha and beta, that minimizes the mean square quantization error, then alpha star minus beta star is equal to dash. Okay, so let us start with this. Then let me explain. So now this is the distribution they're saying. So data is incoming and it is coming with the value such that it varies from -2 to 1 with the probability density given by this. So in this case, if you integrate, let me assume this as some y, then what is this area? Total area integral f of x dx from minus infinity to infinity is this area plus this area. So it is half into, this is 2 into y plus y into 1. This is equal to 1, right? So 2y is equal to 1, y is equal to 0.55. So this value we found 0.5. Now what they are saying, now I have a 1-bit quantizer. So I have a data coming in with f of x given. Now I have a 1-bit quantizer. What is quantizer? It converts your analog data into digital format, and here it is 1 bit. So it can either map to 0 or 1. Right, something like that. But here they are saying they are mapping it to alpha and beta, alpha star and beta star. So how they are mapping it? So if your incoming data is less than 0, then they are mapping it to positive samples to alpha and others to beta. So they are mapping this to beta star, and data greater than 0, you can say greater than equal to, because at one particular point anyway your probability is going to be 0. So this is equal to alpha star. So they're mapping it to alpha and beta, and alpha star and beta star are such that your mean square quantization error is minimized. These are such that your mean square quantization error is minimized. So what is mean square error first? Mean square error. This is nothing but expectation value of your random variable minus whatever value you assume. So this square is your mean square error. So now what is the quantization error? In this you are quantizing it to some value alpha star. So it will be whatever x minus alpha star whole square. This is for your data x greater than 0. Similarly, e of x minus beta star whole square should be minimized for your x less than 0. Okay. So this much only we need to know, and from this we can get everything. So now let us take the distribution. So now you need to find this x as a function of your small x. Okay, x of x. So this is nothing but, so from -2 comma x less than 0. So what is this? So we need to find this equation. So what is the slope of this? It is -2 minus 0, and y-axis we have 0 minus 0.5. So this is nothing but minus 0.5 by -2, which is equal to 0.25. So slope of this is equal to 0.25, and it acts as an intercept at 0.5. So it is 0.25 x plus 0.5. So to verify, if you substitute x equal to -2, this becomes 0, and at x equal to 0, it is 0.5. And for 0 to 1, so x greater than 0, less than 1, what is it? It is just a constant 0.5. So now let us separate these out. So for x less than 0, we are mapping it to beta star. So we have something like this. So we need to choose this beta star somewhere. So this beta star is here. Then my probability distribution will be around this beta star. So it will be this x minus beta star. And that one we are going to take the mean square error and minimize it. So you need to find this ideal location where that expectation of x minus beta star whole square is minimized. So d by d beta star of this should be equal to 0 such that there is a minima. So can we find this value, expectation of x minus beta star whole square? It is nothing but integral your x minus beta star whole square and into f of x dx from minus 2 to 0.5, sorry 0. Okay. So now f of x, you know, this is minus 2 to 0, x square minus 2x beta star plus beta star square into f of x is 0.2x plus 0.5 into dx. So this is nothing but minus 2 to 0, 0.25 x cube minus 2, 2 into 0.25 is 0.5 x square beta star plus 0.25 x beta star square plus 0.5 into this thing. So plus 0.5 x square minus 2x beta star into 0.5 will be just this plus 0.5 beta star square into dx. So can we just club it up, 0.25 x cube minus or plus 0.5 minus 0.5 beta star x square, and the next terms are plus 0.25 beta star minus beta star, right? So it is beta star square minus beta star into x plus 0.5 beta star square into dx. So can we integrate this quickly? So x cube by 4 will get, right, 0.25 into x power 4 by 4 plus 0.5 minus 0.5 beta star into x cube by 3 plus 0.25 beta star square minus beta star into x square by 2 plus 0.5 beta star square x, and this from minus 2 to 0. So 0 everywhere it will be 0, we just need to do minus 2. So minus of 0.25 into 2 power 4 by 2 power 2, which will be 4 plus 0.5 minus 0.5 beta star into x cube by 3. So x cube is 8 divided by 3 plus 0.25 beta star square minus beta star into 2 square by 2. Again the minus sign you need to take care. So since this is cube, this will be minus plus 0.5 into minus 2. So minus beta star square. So now we have to simplify this. So this is 1 minus 8 into 0.5 is 4, 4 by 3 plus 4 by 3 beta star plus 0.5 beta star square minus 2 beta star minus beta star square. So this is equal to minus of 1 minus 4 by 3 is minus 1 by 3 plus beta star we can take it together. So it is 3, which will be minus 2 by 3 beta star, and this minus this is minus 0.5 beta star square. So finally what do we get? 0.5 beta star square plus 2 by 3 beta star plus 1 by 3. Now we have to take and minimize this. So d by d beta star of your expectation of x minus beta star whole square. So this will be beta star plus 2 by 3 equal to 0. So your beta star value is nothing but minus 2 by 3. So if you position your beta star such that it is equal to minus 2 by 3, then you will minimize your mean square error. Now for the alpha case, you can either do it through the same way or intuitively also you can see where if you place it will be minimal. So this is 1 and this was 0.5. So you think and say where to place it so that it is minimal. Of course it should be at the midpoint. So your alpha star should be equal to 1 by 2. So if you solve through the same method also, you will arrive at this answer only by intuition. So how by intuition? So once you place alpha star here, your x minus alpha star is gonna have a symmetric distribution. So neither the negative side is higher or the positive side is higher. So that will be giving you the minimum value for your mean square error. So now you have both your beta star and alpha star. What they're asking us to find? Alpha star minus beta star. So you need to take care of the signs also. So it is 1 by 2 minus of minus 2 by 3. So it is equal to 1 by 2 plus 2 by 3, which is equal to 3 plus 4, 7 by 6. So this is equal to 1.167. So rounded off to 2 decimal places, so it is 1.17.